Did you know that even though 33% of Australia's emissions come from electricity production, the New South Wales school curriculum doesn't teach anything about understanding home electricity usage? We know that school students today do care about climate change, but are we giving them the tools to know the difference they can make with their everyday actions? To solve this problem, Team Delta has designed the Big Greenhouse. This is a scaled home with working lights and appliances that models typical home consumption patterns. Individual subsystems simulate 4 categories of home consumption: lighting, heating and cooling, water heating, and other appliances. The Big Greenhouse also has its very own working rooftop solar system. We'll roll out the Big Greenhouse to schools across the state equipped with classroom learning units designed for integration into the New South Wales school curriculum. This goes hand in hand with the house's interactive learning environment. There's also a user manual with usage and key feature instructions. Students will then see the lessons they've learned personified in their own homes to equip them to take a degree of ownership over their personal electricity consumption.
Our Big Greenhouse is designed using Fusion 360, a versatile CAD tool which provides an easy way to create 2D laser cutting profiles from our 3D models. The design used adjustable parameters which allowed changes to the dimensions of our house to be made easily and quickly. The design choice of having a 2-story and 4-bedroom house considered both the visual aesthetics and the practical requirements of our house to be an effective educational tool. This design used Rhino software to configure the components for our laser cutting process from plywood, which used the Trotrex Speedy 400. This process is scalable and allows for the eventual rollout of big greenhouses all across Australia.
Our Big Greenhouse has LEDs and motors to simulate common household appliances in each of the 4 categories. Components are soldered into their own PCB, plugged into the central circuit board and into mains. This makes the whole system modular and easy to install. Just plug wires into the right pins and you have a working component. If one part fails, replacing it is easy. Just plug in a new one. Pins for power and ground are clearly labelled to avoid mistakes in connections. PCBs sit either inside their appliance or in the custom roof cavity, so all wiring is hidden but accessible. The house operates at 5 volts, a voltage used in common appliances like phone chargers. The components are in parallel, like in a real home, so if one part fails, the others will all be fine. The components are scaled up in the display to correspond with real home consumption values. A 12-volt 5-watt solar panel simulates home generation with a switch to allow to power the lighting system.
The house uses 2 microcontrollers to collect and display power usage data from the house. The Arduino detects which components are switched on and calculates the amount of power used. Then, a Wi-Fi chip displays the data via a web page that can be accessed from a laptop or phone. Besides just the data, the teacher or student has access to the user manual, the syllabus, and a help/FAQ page for troubleshooting any potential problems. The students can also download the data and open it in Excel with a provided template.
Finally, to make the Big Greenhouse really feel like a home, we've added furniture and appliances. The pieces are designed on Fusion 360 with the electrical PCBs in mind. We've also used laser cutters to make the furniture pieces, as it's quick and easy to mass produce. The pieces that are more intricate have been 3D printed. And finally, the furnishing has been implemented last into the system to accommodate for any changes. The first complete prototype of our Big Greenhouse is both functional and highly professional in appearance. A switch corresponds with each component, which is completely operational. For example, when we flip the solar switch, we see it power the lights. All the beautiful furnishings are installed in the kitchen, lounge room, bedroom, and bathroom laundry. Finally, we can see the computer display give us live updates as switches are turned on and off and solar generation changes. The interface has tabs for different syllabus units to make classroom access quick and easy. Overall, Team Delta's Big Greenhouse prototype is both aesthetic and demonstrates technical feasibility. The design provides an interactive and fun way to teach high school students about home electricity consumption and generation. This allows them to better understand the role of their everyday actions in contributing to climate change, which can ultimately empower them to effect change.